Welcome student, and then here we come to our lab exercise, online lab exercise. This is your third exercise, and then I hope you are doing good. And I have also created a questionnaire that asking you about the situations of our course. So whether you want the videos, yeah, whether you want my hat on the videos, my face on the video or not, whether our assignment is too many, so you want to decrease the amount of the face-to-face exercise, or you want to decrease the amount of the on exercise, etc., etc. So tell me something that you think that's not really good, and then we can improve because it's almost half of our class. So we still have the chance. We are still preparing all everything. And again, I'm deadline fighter. So now is typhoon number 8, and I'm still preparing the materials for you. Yeah, let's come back to our online exercise. And it's good that for every videos, so for every 2 weeks, the online exercise is always the most popular viewed on my YouTube channel. So that's good, right? So we focus on the exercise part, and it's important because for the exercise, so you know most, or you can learn more. You can learn the most from our class. So we have mentioned about the regressions. We have mentioned about the clustering. So it's time that we want to do something that we can apply to our data, apply to our data analysis, and then especially in the healthcare data, so we can do something. And then again, this class is not only about the AI, we also have the DA, right, data analysis. And then how the health data can be analyzed by using the AI method, by using the regressions, and then clustering is the important things of this exercise. So here we will use the most, I guess, the most simple or easiest tools for you to handle the data analysis that is Excel. It's Excel. So we will have the square chart, and then to visualize the distributions of different variables. And then we'll also learn how to use the regressions in Excel, linear regressions in Excel. We'll also learn how to use the clustering to improve the linear regressions result accuracy, decrease the error of the Excel. So we will do it once. So again, similar to different lab exercise, we will have the scenario. So the scenario, now we are working on a instrument data. So usually you have the charge, right? So charge always based on different kinds of things. So charge may be based on the age, maybe based on the children's, maybe based on the you are the smoker or not, the BMI value, etc., etc., etc. Okay. So we want to estimate the charge. So for example, Mr. Wong, again, 45 years old, office worker, and then uh, he has a family, 25 years old, wife, etc., etc. So his situation is listed here. We want to estimate the charge of Mr. Wong, and then yeah, how many Mr. Wong should give to insurance company. So honestly, if you buy the instrument in 20 something, so the money is just a little because the risk is low. But when you go up, when you the age increase and increase, your charge will be higher and higher. So we want to find the relationship between the age and the charge of the instrument. So these two. Of course, inside the data, you have lots of different columns, but we only focus on the age and charge of this online exercise first. So we have find a data set. So similar to the cats and dogs database, we go to the same website and then find the data set. So it's this one here. So yeah, minimize my window. So you can see that here you have to download. So you can just download the data set. The data set is in CSV format. So you can use the Excel to double click and then open this CSV format. So it contains the age, sex, BMI, children, smoker, region, and the most important thing, charge. So in this exercise, we are just looking at the age and also charge. So charge will be the white, right? So they are dependent variables, and then they depend by the input data X. So X is independent variables, and then the independent variables in this exercise will be the age. So we have this tool. We want to find out the variations. The first thing in this exercise, remember to save it X, not CSV. You have to save Excel. Okay, save it Excel. Save it and then put it into another name. For example, it should be instrument tool or exercise 3. Okay, you can put it exercise 3, save it Excel because lots of the function you cannot be saved. If you are using the CSV file is only a text file, and then they cannot save the graph, they cannot save the equation, they cannot save lots of the information. That's really important. Okay, so yeah, that is our data set right now, and then we want to find the relationship between the age and the charge. Okay. So yeah, we have download the data set, and then the first most important thing is save Excel file. Okay, always remember save Excel file. Otherwise, all the work you have done, and remember that this exercise will be extended in your face-to-face exercise. So you have to save your Excel file. It helps a lot. Okay. Then, yeah, and usually I would say that for all the data analytic questions, so the first thing you need to do is understand the distribution, understand the relationship, or all the data. So, the first thing, yeah, plot the graph with the graph. So it's easier for you to understand all the situations and then understand all the relationship with different graphics. So it's easy. So usually in the Excel file, we just select the charge and also the age using your keyboard control button. Step both of them, insert, and then chart, scatter chart, scatter plot. Okay. Now you can see that a graph is plotted here, right? So yeah, it's here. So the x-axis will be the age. So starting in 20, maybe 18 something or 16 something, I can't remember very well. So we have around 1,000 something data to 60 something. Okay, to 60 something. So those are the charge distribution. So you can see that if the age is low, so most likely, so the charge will be lower. When the age is increased, so the charge will increase. But of course, they also based on the different situation. For example, they are in our data, they are the smoker or not, or they have the higher BMI or not, overweight or not, etc., etc. So even if they are 20 or 18 something, so the price will be still is in different situations. So here is the distributions. So after you have the distribution, it's great that you understand a little bit about the data. Then we will try to do the regressions. So the regressions of in Excel is really easy to do it. So we have the liners. Okay, this one liners. So before I use the liners, so you have to understand something about Excel. So Excel, so we have the I would say the address of different cell. For example, address of this cell is G2, and then this one is G3. H here, for example, this one 18 is the value. The address is A3. Okay, it's A3. So by using the address, we can easily find out the data that we need and then select the range, etc., etc. So I hope that you have learned the Excel in your high school, Excel, remember? But if you haven't learned the Excel in your high school, try to learn it now. Because one of your comments from from our evaluation is our course or your program, OT and PT, we haven't teach you a lot about the Word, Excel, PowerPoint, etc. At the very beginning, we think that as a university student, you can learn it by yourself, but it seems it's not the case. So it's good that you have the exercise and then you experience a little bit how to do it because Excel, they can help you to do lots of the calculations. So here we use the liners, so you can read the linear equations. We can understand the linear equations, how it works. In fact, it returns y equals to mx plus c. Okay, mx plus b. This one is the y-intercept. C is better, so I change it into c. Okay, um, um, y-interceptions. And then for the y-interceptions, so and then the slope is easy to calculate. So we just find a cell here. For example, I find a cell right there, is k, and then I will type in equal, and then we can just copy and paste. I prepare for you equals minus, and then the range of the y value and then range of the x value. So you can put the equation directly here. Okay, you can just put the equation directly here, and now you can calculate the slope m and then the c y equals to mx plus c, right? So they will calculate the slope here and then also the y-interception for you, easy, right? Just a single click. So by looking at the function here, so not only copy and paste, for example, I want to select the data or I want to understand the parameter a little bit more. So you can press this function, okay, function. So there is a UI, user interface for you to input. So you can change the Y value, you can change the range of the X value. So if you want to change the Y value, so here you can press this button and then select, for example, I select the value from here, G2 to G to 1300 something, right? Yeah, very fast, very fast. Yeah, 1339. So input the data here. So now the range of the y will be G2 to G 1339. And then the value of the x data will be A2 and then A 100, 330, 39. Okay, so press enter. Again, we can calculate the slope and then the equation right there is pretty easy and then pretty yeah, it's easy to do it. Okay, so linear regression in Excel is easy to handle. So yeah, that is the case, and then we can calculate the number right there. So now the linear regression that they have asked on by Excel will be y equals to 250 something x, that is the slope, plus 3160 something. So that is the y-intercept. So if you want to visualize the linear regressions of this one, your results, so it's easy. So I guess you can understand this one, right? So even the primary school student, so they know how to plot a graph. So you have the x and y, right? So x can be start from 1, 2, 3, etc. So we select 1, 2, 3, and then somehow the Excel can help us to generate. So you can enlarge it. For example, I want to generate the x from yeah, 70 something maybe, from 1 to 70, because x will be the independent variable. So they just follow 1, 2, 3, 4, 5, similar to h, right? H here. But the y is dependent variables. So it based on the value of x. So here will be equals, we type in the equation, y equals to m here, x, mx times x plus c. So it's mx plus c, right? But we have to do something because here the address of the slope and the y-intercept will not change. So we will have the dollar signs of the k and then of the 2. This one is the slope and then this one is the y-intercept. They will not change. So the equations will be dollar sign k, dollar sign 2 times O2, that is the x here, plus the y-intercept, dollar sign L, dollar sign 2. So press enter, and then you have the estimated y if the x is equal to 1, h1. Then you can just extend all the data until 70. So Excel is good. They will calculate all the things to you, okay? They will calculate all the things to you. So once you have the x data and then y data, so somehow you can also visualize the estimate linear equation y equals to mx plus c here. So select the graph right click, and then yeah, we want to select more data. Select one more data, the x-axis here, we want to select here, the x-axis, and then the y-axis here, we want to select the value right here. I'm lazy, so I just select the whole column. So if you want to select the range, you can similar form the equation just like this one. You have the range, but I select the whole column. And okay, so you can also change the labels. You can also change the graph plot, etc. But I'm lazy. So just click OK. Then wait for a minute. Hey, what's wrong? Yeah, it's low a little bit, but it's here. Okay, so can you see that there is a linear equations here from x equals to 1 to x equal to 70, as I remember. Yeah, 70. So the linear equations will be a 9, linear, right? Linear equation, so it will be a 9. So this one is y equal to mx plus c is this equations, and then you will have the estimate graph. Here is interesting, and then you can visualize the estimations of your graph. So yeah, we have do the exercise right there here. And then you can also use the linear equations to estimate. Yeah, you have the linear equation, right? So of course, I want to estimate the age and then the estimate charge. For example, here we have the estimate charge here. So the estimate charge again is equal size. I want to type in the equation right there. And then it will equals to m times age x, that means x plus c, mx plus c. Again, we want to log the adjust of the slope and then y-intercept. So the whole equation will be like this one, right? So now we have the estimate charge. Of course, the estimate charge will be different from the true value, the charge here. Okay, so we extend the charge right there, extend them to all. So for this 1,000 data, 1,000 something data, 300 something, now all of them, they have the estimate value. Okay, they have the estimate value. And then, of course, the estimate value, they will have the error. The error is the difference between the estimate value and also the charge. So we can type in error and then see what is the error between those two. So so remember the slides, right? So we want to find the error. Error should be absolute value. So we use the ABS, absolute value, okay? ABS value, and then calculate the charge minus the estimate charge. So we find the difference between these two extra value. So in this case, so the real charge will be 16,000 and then the estimate charge will be 8,000. So the error is high, right? It's 8,000 something. So it almost double the or half of the charge. The error is not so good. So we try to here again extend the, I'm sorry, I missed one thing. So you can see that, right? I miss one step here, the charge. Yeah, no, I have ABS. Yeah, I have. So they will try to calculate the difference between charge and estimate charge one by one for you. So here I try to extend the equation. Here, select it, extend the equation, extend the equations. It's good, right? So after you have extend the equations, now all the different data, right? One data, two data, 1,300 data, each of them, they have the error. And then now we can find the FH of the error. We just type in FH and then select the range. So the range will be here. So it should be I2 to the I 1,339. Yeah. Here will be the error, right? So the error will be now 9,000 something. So you can also extend it into the other cell. So you can see that, yeah, honestly, the charge of all the case, the average is 13,000. And then see that? The estimate charge for all the case, they are similar. Okay, because for the linear equation, they want to minimize the errors for all the case. So if you say that the charge and then estimate charge, their average are almost the same, usually almost the same because of the linear regressions. But if you calculate the error case by case, case by case, right? And then you take the average for each case, the error is up to 9,000 something. So it's huge, right? The average of the charge is only 13,000, and then the error comes out to the 9,000 something. It's really huge. So honestly, this linear equation is not really good for, yeah, we have finished this part. The linear equation is not really good for this part. And then we have to do something. We want to improve the results of the linear equations. So by looking at the data, so we move back to the data here. Yeah, to move back to the data here. So by your eyes, or I would say that by your IQ, okay, by your IQ level. So you can observe that, so the age distributions and also the salary. So you can say that, hey, can you see that here is one cluster, one group. Here is another cluster, another group. Here is another cluster, another group, right? So yeah, you can see something, right? Some cluster according to this graph. So can we use the clustering to cluster the graph and then do the linear regressions and then improve the error? So our objective is reduce reduce the error, improve the error. So can we cluster it first and then reduce the error? And then that is the second part of your exercise. So here I want to introduce one more thing to you. So yeah, Stat Kingdom. Stat Kingdom, if you do not have the money to buy the IBM SPSS to do the statistic, so honestly, there are lots of online tools that you can use. Statistic Kingdom is one of them, and then you can help you to do the clustering. So in this case, for example, I want to do the clustering, and then yeah, I want to put the age. Yeah, first one. I want to have one more things called ID. Okay, ID because I want to copy um, the number into the stat kingdom. So with a ID, it's easy to locate each data instance one by one. So I just give a unique ID to all this 1,300 something data. So after I have put the ID, so the first thing I do is Control C, the ID into here. Yeah, I have Control C, right? Yeah, I have Control C. I'm sorry, I need to be slow. So we can remove the white space here. So we have the ID, and then we want to put the age right there, age, and then put it in on our data. So we put the age here. So remember to remove the first one, age, because yeah, it will return an error. So remove the age, we just put all the data inside, and then type in this one is age. Then we copy the charge here, column G, charge. So we select all the, using your shift, and then select all the charge. Yeah, select all the charge here. Okay, Control C, and then Control V. So we have the charge here. So they are running the k-mean clustering. K-mean clustering, that means find the nearest point for all the data instance. And then you can select how many cluster I want to do it. If you type in 0, that means they will automatic cluster, the k-mean clustering will automatic cluster for you. But by observations, perhaps we can cluster into 3 groups, right? We can cluster into 3 groups. So the k right now equals to 3. Okay, so we have k equals to 3. And then the default value is repeat, and then we do not want the normalizations, standardizations to 0 to 1, just let them to do it. Then press calculate. So after you have pressed the calculate, so it's good. So they have plot the graph for you. So if you still remember, this one is the distributions. So here you have now the blue here, it's the cluster 0, right? So they cluster all the thing into 0, 1, 2, 0, 1, 2. So you have the cluster 0 similar to our distribution. You have the cluster 1 blue. You have the cluster 2 red, right? It's similar to distribution in our Excel. You can also show the central point of cluster 0, cluster 1, and cluster 2. So I'm sorry that I cannot find the center point. So we can enlarge the center point by clicking here. This one, yeah. Can you see that the center point? So the cluster 0 center point is here, right there. Cluster 1 center point is here. And then the cluster 2 center point is right there. Okay. So this graph helps you to do lots of the plot. Okay. So you can also export them into the JPEG, or you export them into Excel to continue your calculations. They also give you the SSE, they also give you the error, etc. It helps you to do the calculation. But the things we want to do it and put into Excel is here. Control A, select all. Control A, Control C, copy. Control V to your Excel file. So here we have come back to our Excel, and then we insert one more column first. Insert one more column. Yeah, it's okay, also okay. So we here, hey, cut, say that is cluster, and then we put all the cluster here. Okay, so we have the cluster 1, 2, 3, 0, 1, 2. Okay, 0, 1, 2, 3 cluster. So now we can do something that is more interesting. So yeah, we can copy. You can keep the data, but I strongly recommend you to copy. So we copy, and then create another spreadsheet. Say we only want to see the cluster 0 and then work in the cluster 0. Copy all the things, okay? Copy all the things. And then now we want to do a sorting. So the sorting here, we do the sorting and then sort all the data by using the clustering. So the clustering is clustering, column J. And all the cluster 0 is here. And all the cluster 1 is there. So it helps you to do the calculation, and then it helps you to do all sorts of the linear regressions. Okay, so you can remove, or you can just copy this kind of data into another spreadsheet. So you can do it later. We can just work on the cluster 0, because for the online exercise, I only request you to work on the cluster 0. Okay. So in your online exercise, right there, yeah, online exercise, we go back to our lab sheet. Yeah. Now you have do the clustering, and then all the cluster 0 is here. Okay, cluster 0 is here. So your online exercise is repeat all the things in step 4. Yeah, step 4. So again, plot the graph, do the linear regressions, calculate error, compare the error of cluster 0 and with all the data set to see that there is an improvement or not. Okay. So the whole exercise is not so difficult because I've also prepared the Excel. Yeah, I've also prepared the Excel for you here, Excel. So I've all cluster all the, I find out all the cluster zero, and then you can repeat the step 4. Yeah, you repeat the step 4 here, and then plot the graph, and then calculate the linear equations y equal to mx plus c, and then calculate the error one by one, one by one. So you just repeat all the things in the on the Excel that we have done before, and you can finish this exercise and submit. So yeah, enjoy your time, and then hopes that you will start from step 1 and do the whole exercise step by step, one by one with me. Otherwise, when you are facing the face-to-face sessions, it will be your nightmare. Okay, good night, and then keep safe in the typhoon.